Okay? So our next problem is obtain the value of Ix using Thevenins and Nortons. Okay? So as you can see, this time, we have a circuit that contains a dependent current source, which is current control. This is now the use of the relationship between open circuit voltage and the short circuit current, the one that I have written in the previous video, no? That V sub O is I short circuit times R sub O. Because this will be the relationship that you will be using to obtain what is the looking back resistance, V sub O all over the short circuit current. We can no longer use the analysis that we have previously, that replace your current sources by an open circuit and replace the voltage sources by a short circuit. In a way, if you will be applying that analysis, it will look like this. If you will try to obtain the looking back resistance across these terminals, terminal 1 and terminal 2, and replace everything by their equivalent internal resistance of open, how about this one? If you replace this with an open circuit, meaning 6I1 is 0. If 6I1 is set to 0, the meaning of this is I1's value is 0, which is entirely impossible because we have a current source here of 12 amperes that is causing the flow of I1. Okay? That will invalidate that analysis. That is why we need to make use of this relationship. I repeat, whenever we have circuits containing dependent sources, you need to make use of the ratio of the open circuit voltage to the short circuit current to determine what is the looking back resistance. Okay? So let us now try to find the open circuit voltage. First, no? Solving for the open circuit voltage. Okay, let us try to redraw your circuit again. Sometimes redrawing the figure will help you analyze more closely. This is terminal 1 and terminal 2. 12 amperes, 40, 10, 5, 6I1. This is our I1. Ito natin to, no? I1. Okay? And if we will assume that this is more positive than the other one, okay, what is the open circuit voltage across this part? This is supposedly downward. Okay, let us assign your circulating currents. The circulating current in this closed part is negative 12 amperes, correct? So this one is negative 12. The circulating current in the other part is negative 6I1. And the circulating current in this closed path is negative 5 amperes. Okay? We will start by taking the relationship between your I1 and its adjacent circulating currents. Remember that your I1 is the difference between two circulating currents, namely negative 12 and negative 5. So your I1 is negative 7 amperes. So we already have the value of I1. So if we have the value of I1, you can also determine the value of negative 6I1. So every currents now are obtained, and we can easily obtain by computation the value of the open circuit voltage between these points by applying your KVL in this closed path at loop X. Okay? So if we start, dito tayo mag-umpisa, we will start in this part. KVL at loop X, that is 10 ohms times negative 12, correct? 10 ohms times negative 12. The other one, yan, minus 10 ohms times negative 5 minus 40 times negative 5 plus 40 times negative 6 I1, but I1 is negative 7. Yan. From plus to minus, we will now go down from plus to minus. Minus the open circuit voltage is 0. Okay? Okay. Plus 10 minus. So the open circuit voltage is equivalent to 1,810 volts. That is V sub O. Okay? So ilagay natin dito. V sub O is 1,810 volts. Questions? Okay? We are already through in finding for your V sub O. Next is the short circuit current. Okay, let's try to find now your short circuit current. Okay. Tanggalin natin to. Oh. Try to clear this up. Short circuit this one. And obtain what is this? I short circuit. Okay. We also have here the kumituin muna natin to. The circulating current in this part, let us say this A. So by inspection, we have two unknown circulating currents. One is negative 6I1 and the other one is A. We can formulate the first equation by applying your loop current equation at loop A. And that will be, this is 10 ohms, 10 plus 40, that is negative 50. Negative 50A plus, correct, plus 10 times negative 12 plus 40 times negative 6 times I1, and that is set to 0. Where is I1? Ito yung I1. You need to express your I1 in terms of the other circulating currents. What is relationship you can derive out of this? Your I1 now is the difference between two circulating currents, namely negative 12 and A. Correct? So if we try to substitute that value, okay, we will now have negative 50A plus 10 times negative 12 plus 40 times negative 6 times I1, that is negative 12 minus A is 0. We only now have a single equation containing a single unknown. So if we try to distribute negative 50A plus, correct, plus 40 times 6 times A, and this is negative 10 times negative 12 minus 40 times negative 6 times negative 12. Correct? Let us try to take a look. 40 times negative 6 times negative A, that is positive 40 times 6. 10 times negative 12. We try to move that in the other side. Kaya meron, that is why we have here negative. Then this one, 40 times negative 6 times negative 12. 40 times negative 6 times negative 12. We try to move that in the other side. We have there your negative sign. And solving now for A, the value of A is negative 14.526 amperes. Okay? Knowing now the value of A, we can easily obtain your short circuit current. Simply, the circulating current in this part is negative 5. Correct? Yan. So, what is now your short circuit current? Short circuit current is the difference between A and negative 5. That is negative 14.526 minus negative 5. Short circuit current is negative 9.526 amperes. Okay? So we can obtain now your looking back resistance. Open circuit voltage is 1810 divided by your short circuit current of negative 9.526. This is negative 190.006 ohms. This will give us a value of Ix by Thevenin's and Norton's. Ix is the open circuit voltage of 1810 divided by negative 190.006 plus your RL of 20, that is negative, the value is negative 10.646 amperes. In the same way, that can be obtained also using your Norton's. Short circuit current of negative 9.526 times R sub O of 190, negative 190.006 divided by negative 190.006 plus 20 ohms. Your Ix is the same, that is negative 10.646 amperes. Okay? So as you can see, whether you solve this by Thevenin's and Norton's, the result is always the same. Okay? If you want to validate more, then of course you can try solving the same problem by the use of another way, another means. For example, by loop analysis. Let us try to solve this by loop analysis. If we try to solve that by loop analysis, the circulating current here is negative 12 amperes. That is negative 12. The circulating current here is unknown, that is A. Circulating current here is negative 5. Then the circulating current in this one is negative 6 I1. Okay? So if we start by applying your loop current equation at loop A, loop current equation at loop A, that is negative A times 10 plus 40 plus 20, correct? Plus the adjacent circulating currents plus 10 times negative 12 plus 20 times negative 5 plus 40 times negative 6 I1, and that is set to 0. We need to express your I1 in terms of the other circulating currents. What is I1 equal to? Your I1 is the difference between negative 12 amperes and A. So this is negative 12 minus A. So this is negative 70A negative 70 times A plus 10 times negative 12 plus 20 times negative 5 plus 40 times negative 6 times I1, that is negative 12 minus A, and that is set to 0. And you can have the value of A, if you will try to simplify this, negative 14.526 amperes. Okay? How do we come up with this? So that is negative 70 times A minus 10 times 12 minus 20 times 5 minus 240 times negative 12 minus 240 times negative A is 0. All the variables should remain in the right side. Okay, negative 240 negative 70A that is negative 70A minus 240 times negative A, and all the constants in the right side, that is 10 positive 10 times 12 plus 20 times 5 plus 240 times negative 12. You will see that A is negative 15.647 amperes. So if you have the value of A, you can determine now your IX. IX is the difference between A and negative 5. So this is negative 15.647 minus negative 5. So your IX is negative 10.647 amperes. Just the same. Okay?